Good morning. Today I'm going to go over this worksheet, North Pole, Zenith, and early Earth measurements. So I'm covering several quick topics that have to do with the history of astronomy. And there's a little bit of intro up here, so you can take a look at that. But then down here, what I want to talk about are these two images. So the first is cover a couple of definitions. And you see in this image a person standing on Earth, and then you see up here it says Zenith. Well, your zenith, wherever you're at on Earth, your zenith is when you look straight up into the night sky, straight above your head. And that is the zenith for you. That is the zenith for your position, straight up overhead. Now, if you are looking up into the night sky, up at the zenith, and you watch the night sky throughout the evening, what you'll see is that the moon, stars, and all the planets are moving slowly, but all together across the sky. And they move at the same pace. So you don't see this like minute to minute, but if you stay there for 1 hour, 2 hours, 3 hours, you'll see all of those objects in the sky moving at the same rate slowly across the sky. Now, the important thing to remember here is that none of it changes over the course of a night. So, like constellations, if you see the Big Dipper in the sky at night, or you see Orion in the sky at night, the stars that make up those constellations, they don't move throughout the night in respect to each other. They stay in their positions, but they just move slowly across the sky together. Now the question is, why is that happening? And it's not, what we want to remember, it's not the objects in the sky that are actually moving. It's that Earth is moving underneath the sky, right? So our view changes as the Earth moves. If we look at this image up here, we also see a north and south pole, this line that makes up the north and south pole, and something called the North Celestial Pole. The North Celestial Pole, this is the point in the sky. If you look north at that position, throughout the night, it'll appear that all the stars move around that point, okay? This is an image on this side. This is a picture that was taken. The North Celestial Pole is right here in the middle. And over the course of the night, this is a long exposure picture. So that means it was exposed for maybe like 2 hours or 3 hours, and you see the motion of the stars. And all this stuff will rotate around that point. That is the North Celestial Pole. That's different from the magnetic North Pole. Something to remember. Now, why does this do that? We talked about the Earth moving, but why does it all rotate around this one point? And that's because Earth is rotating on its axis. So this line that goes through the North and South Pole, the physical North and South Pole, Earth spins around that point. So when you look up into the night sky, you're seeing the spinning of Earth in these trails of the stars over the course of the night. All right, let's get into a little bit of the history of astronomy, some early discoveries. Now, back in around 200 BC, there was an astronomer, a scientist called Eratosthenes. And he was actually able to fairly accurately measure the size of the Earth. He measured the radius of the Earth pretty accurately, pretty close. And here's what happened. So what kind of instruments did he use? Well, he really didn't use much instruments at all. If anything, you would say he used a well, like literal well that you pull water out of, and a column, these tall, 30-foot columns that were used in Greece. So those, if anything, were his scientific instruments. And what started his calculations for the size of the Earth was this observation that on the first day of summer in this town, there was a well. And on that first day, the sun's light would travel all the way down to the bottom of the well. Every other day of the year, it didn't make it all the way down. It would hit the sides somewhere of the well, okay? But on this one day, it would go all the way to the bottom. So it's a straight line, okay? That was what got his mind thinking. So then he said, okay, well, that's if on that day the sun goes all the way down this well, what if I go several hundred miles away and I see at the same exact time of day what is happening with this column in Alexandria? Will it also have a shadow the sunlight goes straight down and leave no shadow? Or will it create a shadow? What he found was that it created a shadow. So that means the sun's light was coming in at a different angle. Now, with those two pieces of information, what he did was he used geometry, where the light coming in from the well was one side of an angle that would make up the radius of the Earth. And in Alexandria, the shadow that was cast over here using geometry, he used as the other side of an angle. And in geometry, the angles of this shadow from the column at Alexandria matched this angle down here. Once you have that information, then you can calculate the size of the Earth. And again, very accurate actually, in 200 BC. Now there was another Greek scientist that also made a discovery early on about the Earth and about how the Earth moved well before any major scientific instruments. I mean, this is well before any telescopes. This scientist, his name was Hipparchus, and he was studying the night sky and positions of the planets and the stars and all of that kind of stuff. So he built an observatory on the island of Rhodes. Building an observatory helped him catalog and collect data of the movement of all of these things. And he just looked up in the night sky and recorded where they went night to night. Now, he did use observations from older scientists from maybe 100 years before, and he compared it to the observations he was making. So he collected a lot of data. When he compared them, he saw that the celestial North Pole, this line, changed over 100 years. Not a lot, but it changed position. So the celestial North Pole was slightly shifted. And what he was able to work out from that, what he was able to figure out is that it changes, the celestial North Pole changes where it's pointing. And what the Earth does, he calculated, has a precession. So, precession. This means that it spins like a top. So it spins around this circle, or that celestial North Pole, over, I think it's 40,000 years or something like that. Just slowly in the sky points in a different direction as it goes around this circle, okay? All right, I hope this helps. Thank you very much.